Welcome to Web Handling. My name is Dave Roysum. In this video, we discuss some groundbreaking work on diagnosing baggy paper. The shape tool is one of my favorite troubleshooting methods. In the case of baggy webs, however, it is more than helpful. It is essential. Simply put, the shape tool says that the shape of the problem must resemble the shape of the cause. In the case of bagginess, shape is the tension or length profile across the width. In the figure we can see lanes of tight and loose, and thus the causes must be lane-like and in those locations. The most useful application of the shape tool is to screen candidate causes. In the case of a single baggy edge, the problem is most clearly different on one edge than it is on the other. In that case, the problem must be different on one edge than the other. The simplest shape meeting that description is a linear taper. Thus, an uneven profile with a central lane or lanes would not be a good candidate because the shape does not match. Similarly, even if tension settings made the problem more or less, it could not be the root cause, as the drive can only move the tension up or down, but could not move the tension of one side up and the other side down. On the other hand, misalignment is an eligible candidate because it has the correct shape. Determining whether misalignment was a good candidate would require additional study. Baggy edges is often a far more difficult problem to troubleshoot than a single baggy edge. There are a couple of reasons for this. First, one of the most common troubleshooting techniques in converting or flipping a supply roll does not provide useful information. Flipping a smile gives a smile. Second, most forming elements are known to possess frown or smile shapes. Examples here include roller deflection and temperature. Unfortunately, the difficulty of troubleshooting baggy edges is far more difficult with paper than it is with other products and processes. The reason has to do with our shape tool that is nearly essential for baggy web troubleshooting. First, nearly every element in a paper machine is a forming element and thus begins as a candidate. Second, there are dozens of these elements in a paper machine. Third, nearly every forming element has a known frown or smile shape. Fourth, these shapes include far more possibilities. All of these challenges conspire to make a paper machine a much more difficult process to work on. One breakthrough on paper machines was described by Frédéric Perron of FP Innovations in Montreal. He showed clearly an inverse relationship between moisture and tension profiles. In other words, where moisture was high, the tension was low, and vice versa. This work was enabled by an invention of a baggy web tension meter that we will discuss in the next module. This baggy web meter and other instrumentation, coupled with some truly clever detective work, uncovered many other causes for baggy paper. Thank you so very much for watching this module in my Plant Practical series. If you want more information about troubleshooting of paper, you must follow FP Innovations. If you want more information on wrinkling, bagginess, and many other web handling topics, stay tuned to this channel for more modules, or, better yet, take my Web 101 video-on-demand courses in web handling and winding.